Fashion Tech Alliance involves higher educational institutions, small, medium and big enterprises and the research center. This project has been co-founded by the Erasmus Plus program of the European Union and is aimed to facilitate knowledge exchange between partners and to design and pilot learning experiences to engage students in a fashion tech residency program, embedding young talents in the company's innovation activities. A central objective of the project is to design multidisciplinary, interdisciplinary and intersectoral learning activities involving international students from 5 European universities. The contents of the lectures have been specifically created to match the needs of fashion tech learning. They have become open educational resources to allow future engagement between a European-wide fashion and textile HEI community and are available under Creative Commons Sharealike 4.0 with the aim of a wide and free distribution, access, use and reuse. Ready to learn more about fashion tech? Enjoy the lecture.
Hello, my name is Douglas Atkinson and I'm a lecturer in Wearable Technology at London College of Fashion. In this lecture, I'm going to be discussing the Internet of Things, or IoT, and trying to problematize the fact that this is really a kind of quite poorly understood definition of connected technologies. And in relation to this, I'm going to be talking to you about novel design methods that have emerged in light of the fact that many connected technologies can have equal agency or equal influence over the world as humans can nowadays. So I will be discussing thing-centered design and some of the methods that are associated with it. The lecture will be structured as follows, beginning with an attempt to define the Internet of Things. Although, as I said, this is a fairly contested definition. I'm going to be telling you some of the things that people have previously proposed might make an Internet of Things device fit in that category, as opposed to being a conventional computing device or just a connected asset-tagged object. So that will involve a discussion of the differences between Internet of Things objects and asset tagging, or the proposed differences. Next, I'm going to introduce wearable Internet of Things technologies, which will again kind of problematize this idea of what makes an Internet of Things technology and how it connects. And then the final sections of the lecture will explore research methods for investigating the worlds of connected objects. So these include thing ethnography and posthuman ethnography, both of which share a commitment to focusing on the world and the engagements of a thing rather than the culture of a human. And finally, we're going to explore thing-centered design, which is an area of design methods that have been developed by TU Delft in the Netherlands to creatively apply the data that you may have captured regarding the life of a thing and to use that in a design context. So, to begin with, what is the Internet of Things? It's a phrase that's used often, but it's very poorly understood, and it has quite a long history behind it. So we'll talk about that very briefly. But first consider, do you think you interact with the Internet of Things already? Do you maybe even carry it with you? So, to introduce the Internet of Things, I'm going to take this example, which is probably the most familiar to all of us. And this is the idea of a smart home ecosystem. And these have been available for a while now as various commercial products from companies like Google Nest or Philips or various others. And they involve items that would not be conventionally connected to the internet and would not conventionally have computing power. So this is one of the first definitions of Internet of Things objects, that the Internet of Things takes objects that are not conventionally capable of computing, of kind of analysing data, of processing data. It connects them to the internet and it gives them that processing power. So that's one way of viewing it, and it's one of the most kind of top-level definitions which still stands up to scrutiny. Another really important factor about Internet of Things objects is that they're capable of communicating not just with your computer or your mobile phone, but with each other. So potentially all Internet of Things objects should be able to network with one another. Now this is something that we see in smart home ecosystems. So for example, if your thermostat can communicate with your security system to tell whether there's anyone in the house, that can then intelligently raise or lower the temperature. For example, other items like connected lighting can register whether you're at home and also can connect to data on the internet around the relative light levels outside. So it can start to feed in different data around sunrise and sunset into the system. It can figure out whether you're in the house, and then it can adjust things accordingly. So those are some of the examples of interactions between different data sets and different objects that can start to, in many ways, streamline your life or help to use energy in a more smart way. So, in theory, every Internet of Things item should be able to communicate with every other Internet of Things item. And we've really only just begun to see the potential of how that could be leveraged. So at the moment, we can maybe use our phone to set our washing machine to put some laundry on before we get home. But that's really just the tip of the iceberg in terms of what multiple connected items can do. So another conventional definition of the Internet of Things, which really started out in the early days of IoT, was that everything internet connected should have an IP address. So an IP address is really just a unique identifier that's assigned to a piece of technology to identify it on the internet. Now this is where we start to see some issues with the definitions of the IoT, because in many of these cases, for example in smart home systems, we will find that the things that are connected to the internet are connected through a hub. They're not always things that have their own IP address. And therefore, although they should be uniquely addressable and each individual and capable of communicating with one another, they don't fit into this traditional paradigm of a device being identifiable by its IP address on the internet. Now that has good and bad aspects. It reduces the load on a wireless connection within an environment, say a home or an office. So it streamlines the amount of data that's being fed and makes things a lot more manageable for the system. However, it also has implications around privacy. For example, IP addresses are traceable. If you give an IP address to everything in your home, you become much more traceable, particularly if some of these objects are mobile and if they tell you about your habits and day-to-day routines. So actually reducing IP addresses in that context can be somewhat beneficial in terms of privacy considerations. Now, given those definitions that an Internet of Things object should be connected, it should be capable of processing data, and potentially it might have an IP address. How does this differ to some of the other kinds of connected technologies that we've started to become used to in our everyday lives? So this is an example from a company that are currently no longer trading, but had the idea of including an NFC tag in a shirt. And NFC tags are the technology that power wireless credit cards, wireless bank cards, also wireless cards for transport systems such as London Underground. And really what they are very small chips which are capable of storing data. So the important distinction here is that they aren't computational. So that's the difference. You can connect an NFC tag, but it won't compute data in the way that some people argue is a core function of an Internet of Things device. So just to give you an idea of the difference in what these different things are capable of, these shirts were designed so that rather than trading business cards, you could encode all of your data, your professional contact details, into the NFC chip in the cuff of your shirt. And then that could be shared by scanning a mobile phone over it, so that perhaps if you were at a conference, if you were networking, you could share your details more easily. Now, this is a classic example of a novelty application for adding data, for adding connection to a device. And I think that's likely why you can't buy a full length shirt now, because there was no real need for that level of data attachment or that functionality. It didn't provide really very many tangible benefits over exchanging a business card. So NFC tags are stores of data, but they're very useful stores of data, and they can be integrated into very small yarns and very kind of tiny footprints, and so they're very easy to integrate now into garments. So they can either be tags, they can be stickers, or even woven in potentially. So there are yarns that are around 1 millimeter thick that can contain NFC technology nowadays. This is an example that you may have come across in garments that you own. So RFID is very commonly used in garment tagging. RFID is a similar technology to NFC. Sometimes they're used interchangeably. NFC is capable of a little bit more functionality and data storage, so they're slightly different. But they're broadly similar technologies. And this is a label from a piece of sportswear manufactured for Decathlon. It's one that has been cut out, but I've personally seen these myself, and they're used to tag quite a lot of their assets. So generally, garments or kind of textile products that have come from very large factories in Asia are often tagged in this way. And the tags are used to follow them through the production chain, so that it's very easy to track how many of something has been produced, at what stage in the production line the actual item might be, and then to use it for logistics to follow how it's shipped internationally and to which retailers or to which consumers. Primarily, it's always focused on the production chain rather than the consumer-facing side of the experience. However, that's not always the case, and it can be leveraged for consumer experience as well, as I'll mention in the next slide. So these are fairly common technologies, and as you can see, if you kind of hold up a label that contains an NFC or an RFID tag to the light, it's really just a very small electrical coil. So that's all you need to carry data, and that's important to look at distinctly from something that can process data. But by carrying data, you can create really interesting interactive experiences. And this is actually quite an old example. So RFID and NFC have been in circulation and in use for quite a long time. And one of the earliest examples of their use in retail was at the Prada Epicenter store in New York, and this was in the year 2000, so this was quite a while ago. What the Epicenter store did with the RFID tagging was to not only use it for inventory and for kind of checking whether something was in stock, but also to link interactive content to an item. So customers could visit the store and they could take the RFID tag to be scanned on an interactive screen or even a screen in the changing room. And that would trigger some kind of bespoke content that was an extra layer of storytelling or an extra layer of useful information for the customer that was attached to the product. And this has been used more recently by Burberry in their flagship store in London, and also is used quite commonly by the Rebecca Minkoff brand in some of their stores. So again, it's a fairly kind of normalized technology, it's fairly stable and in use. And it shows that you can provide someone an interactive experience without necessarily being a full computational Internet of Things object. Now, that example focused really on sales and on kind of driving profit and in kind of creating experiences in retail. Another interesting retail experience focused slightly differently on trying to engage people with the backstory and some of the interesting attachments that people created to garments they donated to Oxfam. So in the winter of 2010, in Selfridges department store in London, there was a pop-up shop called the Oxfam Curiosity Shop. And in this, various celebrities donated garments, and they recorded video to talk about the history of the garment, so talking about their emotional attachment and their connection to it. And these videos were linked to the garments by RFID tags which could be read in the store. So the idea was that through this process and through this data tagging, people would begin to understand the history and develop more of an emotionally durable, more of a long-term connection to a garment, rather than treating it as a throwaway or disposable item. And the interest was in actually building these histories over time to really represent how people might have significant moments or experiences when wearing a garment, and to pass that on to the next person who would wear it. So in this instance, you have Annie Lennox and a dress that she donated. And these tails were attached, as I said, through RFID, which you could scan, and then the embedded video would be played on a screen in store. And this was part of a research project called Tales of Things and Emotional Memory, which did exactly what it said in the title. It tried to promote the idea that we create emotional connections to things through our lived experience with them. And so if we want to keep a garment in use for longer, if we want to understand an object and the role it has in our lives and the significance it has in our lives, we can attach a story to it. And when we know those stories, we tend to value the object more. So there are ways that these technologies to add data to an item can be used to actually create more sustainable interactions. So these can be used to create value, and not just economic value, but social value in relation to how you understand the history of a garment and how you might want to either buy into that history or to appreciate that history and treat yourself as a caretaker of a garment to pass it on and to add your story so that other people might engage with the garment again afterwards and understand what it meant to you. So in relation to some of these technologies, do wearable technologies, do things that we embed in smartwatches and clothing need to process data when we can create these interactive experiences quite easily without the data processing capacity of a traditionally defined Internet of Things object? So let's have a look now at some examples of wearable Internet of Things technologies. Well, these can come in many forms, but perhaps the one that we're all most familiar with is the smartwatch. In a way, the smartwatch was the kind of gateway to wearable technology that started to embed the idea of wearable tech in the public consciousness and show how useful it potentially could be. So, smartwatches are an interesting technology in relation to this question of how you connect to the internet, because quite often smartwatches are connected not directly, but through a mobile phone. So again, we come to this idea of connection hubs that mediate the connection of a technology to the internet. And this is why some definitions can be problematic around what is an Internet of Things device, because now we're experiencing a lot more connectivity through hubs. And potentially, it could even be the case that we don't need particular hubs in the home when our mobile phone can serve the same purpose. So it's an evolving area, and that definition still has to stabilize. Another question around smartwatches is whether the definition of an object that traditionally would not be computational or accessing the internet is really kind of appropriate anymore. So by a traditional definition, a mobile phone, a tablet, or a computer would not be considered an Internet of Things object, because we expect all of these things to have connectivity and processing power. And yet, it's only fairly recently that we've expected mobile phones to have connectivity and processing power. So, we could argue that given the expectation we're seeing now in smartwatches to perform both of these functions, they may no longer really fulfill that role of being an unexpected technology that wouldn't traditionally connect to the internet. And this is another question around definition, in that if we become used to all of our everyday objects connecting to the internet, will the Internet of Things still be defined in the same way when we expect everything to be connected and computational? So that's a question for the future, and it's an interesting one to discuss and to consider. In terms of garments, there are various examples available on the market right now that also represent this idea of connection to the internet through a hub or through a mobile phone. This example are the NadiX yoga leggings, and these are leggings that can sense posture and can provide vibration feedback so that you know how to correct your posture. So in theory, you should be able to assume a perfect yoga pose without an in-person teacher there to correct your form. These work using accelerometers to measure your movement and to measure your position, and vibrotactile motors embedded in the garment. And these are all connected to your mobile phone, which will do the majority of the processing to understand what it's reading and to give you tips and feedback on form. Another example is the most recent iteration of Google Jacquard. Google Jacquard originally began life as a woven touch-sensitive interface using a Jacquard loom. And yet Google fairly quickly discovered that the functionalities of Jacquard, the connectivity, and the ability to sense different gestures and different motions could all be achieved using accelerometers and using technology that was shrunk down into a very manageable, solid item. Effectively, this contains all of the data capture sensors and the connection to your mobile phone that would be needed to read your position and your movements. So if you think to the yoga leggings example, potentially rather than having multiple individual sensors, all of this could be achieved through one sensor, and this is what Google Jacquard are working towards. This, again, is interesting because, in theory, Jacquard is a technology that can move between different garments, and that solves some of the issues around integrating electronics into a garment permanently. Jacquard also solves some of the issues around the connectivity when you incorporate soft and hard electronics into a garment, and generally, the points which wear and which fail the most in a garment are the points where you're connecting hard and soft electronics. And so with this iteration of Jacquard, Google have solved that by taking away any connection. They simply have the solid, hard electronics in one capsule that you can insert into different items. So, looking at these technologies, it seems that wearable examples of connected items generally rely on the idea of a hub within a network connecting the garment or connecting the worn object. Now, it's interesting that this is not a particularly novel idea. This is a design example from Starlab and Walter van Beirendonck from, again, 2000. And they were experimenting with the idea of a fabric area network. So initially, when computers were first networked, you would have the acronym LAN for Local Area Network. And that was really just a way of networking local computers together. In the fabric area network, the experiment was to connect different layers of garments, which each had a different functionality. And this is a very early example, but it represents the thinking that's gone on to inform quite a lot of the devices that we wear on the body today. So, with that in mind, it's worth exploring body area networks. Now, given that many wearable applications are used for healthcare, this is really one of the evolving areas of wearable technologies right now. The idea of connecting not just a garment, not just, for example, a mobile phone or a sensor to this network, but connecting some of the metrics from your own body. So this is actually taking the idea of, say, a fabric area network one step further from something that sits on the body to something that is directly interfaced with the body. And a good example of this can be seen in insulin pumps. So there are now examples of insulin pumps for diabetes that actually are worn on the body that can continuously monitor the glucose levels in the blood and when needed can provide insulin if they detect that the levels go outside a certain range. So this technology actually starts to transgress the idea of what can be worn on the body. It's a look at what can be worn in the body. It actually punctures the surface of the skin. So we're looking at not just on-body Internet of Things, but also in-body Internet of Things as an evolution of some of the healthcare devices that can be connected to the internet. And again, as this image shows, connected insulin pumps are generally connected as part of a kind of hub network through a mobile phone. So all of these ideas are starting to trouble conventional notions of where a network is located, how something is networked, and how the body interfaces with it. And this is why people have started to explore the agency and the roles of some of these technologies, particularly looking at how you can do ethnography with connected objects in thing ethnography, and how you can actually use an ethnographic lens that explores the world beyond the human, particularly in relation to post-human ideas of transgressing the body and cyborg bodies and the connectivity of the body to technology. So some studies looking at insulin pumps have even coined the term cyborg anthropology to look at this combination, this merging of the technological artifact with the human body. But to begin with, I'm going to briefly discuss thing ethnography. So thing ethnography is a term that was coined by a kind of large group of researchers from different universities, led by Elisa Jacquard from TU Delft. And initially, they used visual ethnography methods to look at the lives of everyday household objects. So they equipped objects like kettles and cups and kitchen items with life-logging cameras. And a life-logging camera is a technology that generally captures photographs every time it either senses movement or on a timer over a particular scale, so every 10 seconds or 30 seconds. They were interested in the fact that through this process, they can start to understand how non-human things actually structure our time and structure our interactions with them. So in this example with the kettle, they were interested in how the amount of time that was taken to boil a kettle to make a cup of tea or coffee actually kind of structured people's behavior. So there's an example in one of the images of someone kind of lunging and doing press-ups on their kitchen counter. And for them, the idea of time and interactions with objects is really significant. So from the perspective of the thing, looking at how often it's used and what its life is like outside of its engagements with humans who are using it. So that's a good way of testing whether something is either useful, whether it can be designed in a way that can be shared, or whether it can be designed in a way that actually leverages the interactions we have with it. Or looking at how we could perhaps design an interaction around the time taken to boil a kettle that actually encourages people to behave in a certain way. What can we get people to do in those maybe 2 minutes while they're waiting for a kettle to boil? So how do we guide that interaction? And really, this starts to inform ideas of the culture or the world or the life of a thing. So in the same way that ethnography is looking at the cultures and lives of people, thing ethnography really flips the lens to look at the cultures and the lives of a thing. And in this sense, it's very similar to post-human ethnography. So I've mentioned insulin pumps already. Sarah Doyle from University of Stirling actually conducted an ethnography that she discusses as being a post-human ethnography, looking at the lives of insulin pumps. And she did this by really tracking the insulin pump from its manufacture to its allocation to the NHS, to its allocation to a patient using it and their experiences, all the way through to its end of life, to its either kind of disposal or recycling. Now, if you're looking at, for example, circularity, this has obviously interesting implications for studies of that kind of design. It also has interesting implications theoretically, because it's based in post-human philosophy. which really attempts to remove the centre of focus from humans. And a lot of posthuman theory now deals with the idea that the central focus on human beings has allowed us to create all sorts of environmental problems, to treat animals as lesser beings, to treat the ecosystem as of less importance than the human, and to also treat the objects we consume as of being less importance. So it makes it easy for us to throw things away if we don't really think about the impact of them. And so part of this decentering from the idea that philosophically humans are at the centre of the universe is to try and bring us more into account of the materials we use, the species we interact with, and the impact we have on them, and the world more widely. So for creating sustainable and ethical accounts, post-human methodologies are actually quite important, and they serve to represent viewpoints that wouldn't traditionally be represented. And in that sense, they have a lineage to quite a lot of feminist philosophy and feminist methodologies. But in this case, the following of the insulin pump allowed Sarah Doyle to gain perspectives that she wouldn't have from simply interviewing a patient. So although this was an ethnography which tried to explore healthcare and the social impact of a healthcare technology, she managed to get a wider understanding of how it was used through following its entire life. And that can be really important. Again, when we think about wearable objects, we don't tend to often think very strongly about who manufactured them. We don't often think enough about end of life. And there we can really start to rebalance the way we perceive a technological wearable object, or even just a conventional garment. So it's possible to apply these kinds of lenses to any kind of technology, be it a very simple woven or knitted technology, or be it an electronic technology that we interact with every day. It's really just about understanding what the uses and the temporality of use of these items might look like, what the kind of networks, what other things they come into contact with, and foregrounding those. And those can be a really valuable design resource. So, moving on, I'm going to briefly discuss thing-centered design. And this built on the work that was pioneered by Elisa Jacquard and her co-authors who coined the term thing ethnography, and really looks at designing with the data you get from thing ethnography or from other thing-centered methods. And so this can all be found at www.tcdtoolkit.org. And this is really a collection of methods that are proposed for understanding and engaging with things. So one of which is the idea of an object persona. So creating a persona for a non-human thing that expresses some of the aspects of its life, of its engagements with humans or other non-humans that have appeared in your research. Another is the interview with things, which similarly is about personifying an object or a non-human thing that you have researched. And I'm going to show you examples of both of these in the next few slides. So, object personas can be represented in various ways, but this is an example by Johanna Nissenbaum. And she actually decided to create a diary for a remote control. And if you read through it, it's quite fun, it's quite playful, so it's actually quite an engaging method to use. But it also tells you a bit about the usage of this device, when it's most useful, or when it could be leveraged in a different way. So, for example, the evenings are boring for me, I'm isolated in the corner of the house, maybe my owner doesn't remember me after lunch. Then also discussing the relationships between technologies. I have a love-hate relationship with the tablet. It's a new object in the house. And treating it as though you're really trying to understand how the relationships between a technology that might be superseding an old technology, or the fact that a technology might take on functions of an old technology, could be perceived. So just trying to embody an item that tells you a little bit about what its concerns are. For example, if you were going to embody a high-tech running t-shirt that could monitor your vital signs, would the running t-shirt be jealous of your smartwatch? Would they work together? Could they work separately? How does it feel about constantly being connected to your mobile phone? How does it feel about being laundered? Does anything need to happen to make it washable? So understanding all of these things from a slightly anthropomorphized perspective, although it's not fully taking the post-human sense of really decentering from the human, we can never do that 100%. So this idea of anthropomorphizing and personifying something helps us to perhaps think outside of our usual understandings of a technology and to look at it slightly differently, in a slightly more post-human way. And in Interviews with Things, another project that was quite interesting, which was developed again with Elisa Jacquard's research group, was interviewing a scooter in Taipei. So it was looking at the use of scooters in Taipei, which is a very crowded city. A lot of people use motorized scooters to get around. And in this study, a set of scooters were tracked using cameras and using GPS tracking to try and find out a bit about the journeys they went on and who and what they interacted with. And with all of this data, it was kind of produced so that you could see timelines of images, so you could start to reconstruct the daily life of a scooter. And these timelines, the GPS coordinates, and notes that the researchers had made were then handed to groups of actors. And the actors were asked to personify a scooter. They each had a set of data from a different scooter. And then the research team interviewed the actors to ask them about their experiences, about their day, about what they'd seen, heard, and felt. So these are actually quite nice methods to start to get you to think about embodying or personifying either a technological wearable or even a normal wearable. So think about whether you could describe a day in the life of a fashion thing. What might you learn? What might it tell you to know a bit more about whether a jumper feels neglected being left in the wardrobe, or whether something feels like it's being washed too much and is worried about falling apart? What does that help you to understand? Because in a way it foregrounds understandings you already have about a garment, but reframes them in a way that might make you think differently about them, or might make them seem more like pressing concerns. So, to conclude the lecture, I want to invite you to think about what new perspectives you can gain from researching things, and particularly connected things. So all of these thing-centered methods have come about because of the realization that now lots and lots of the objects and things we engage with in everyday life are capable of collecting data. There's huge amounts of data that can be collected by our mobile phones and by all of the things that are connected to them in various ecosystems, if you consider your phone a hub. So thinking about who and what else interacts with the thing before and after its life with you. And that doesn't just mean when you bought it or kind of discarded it or it goes to be recycled, but even when you're not necessarily engaging with an object. What goes on in its life? How is it used? And how could it be used differently? So that really ties into the idea of what happens when you're not using something. And as I'm very interested in interaction design, can you consider how to design interactions with an object, particularly a fashion item, that makes you use it more sustainably? So use it more often, consider how it's used, and actually sustain your engagement with it, sustain your interaction. So thinking about that, also consider how an object or a thing structures your behavior or your time. What might you do while you're waiting for your clothes to be washed? How might the feeling of a garment even structure your movement? And how might these things impact on your time, on your daily routine? So really thinking about the role that non-human things have on the way you engage with the world and the things that you do. And then finally, what technologies and networks do the things around us come into contact with on a day-to-day basis? We can very easily read what networks are available to connect to from a mobile phone or a laptop, but do we ever consider that in terms of a garment? So perhaps it's time to consider how many different Wi-Fi networks your garments could connect to on a day-to-day basis. And should you connect to them? Do you need to? And are there ethical concerns around the tracking and the traceability of your garment and you if you connect to more networks or if you connect to more smart objects? So these are all considerations to think about as we design things that become smarter and more connected. And I hope that that's given you a lot to think about when considering not only how you might define the Internet of Things, but how you might consider whether or not you can and should design connection and computation into day-to-day wearable devices. Thank you.